We are team 2 for the 502 project presentation. This is Gautam, and my contribution for the project is I worked on runtime and grammar generation.
Hi, I'm Pramod. I worked on the intermediate code generation and the parse generation.
Hi, this is Satish. I worked on the intermediate code generation and the parse generation.
Myself, Dikshit, I worked on runtime in Java.
We are team 2 for SER502 project presentation, and we are going to present our programming language, which is called Infinity. And my team members are Pramod, Satish, and Dikshit, myself, Gautam. So we are going to discuss about our programming language, Infinity. We are going to cover the design of the compiler and the intermediate code generation and the design of the runtime and the demonstration of the language and few examples how it works. So the basic components which Infinity has are Antler, which composed of scanning, parsing, and intermediate code generation. And we have used Java for the runtime development. So now I'm going forward and explaining how Infinity works. So our source code is recognized by .inf, that is .infinity file, which is pushed into the parser, which generates a bytecode. So that bytecode is recognized by .inf.byte. So that is like source code.inf.byte, which in turn will be pushed into the runtime and which creates an executable file. Infinity. In Infinity, we have implemented these operations and data types. The data types are integer and boolean, and we have also implemented assignment operator and all the conditional statements less than, greater than, equal to. Infinity also supports mathematical operators, addition, subtraction, multiplication, division, and modulus. And it also supports decision constructs and iterative constructs like if, else, and while. So Infinity follows the syntax of C language, similar to C language syntax. And I'm going to tell you about Antler. Antler, which is another tool for language recognition, is a language tool, is a framework that provides it provides framework for constructing recognizers, interpreters, compiler for the given grammar input. Antler supports a grammar type called .g4, which is very close to extended backwards normal form. Antler is composed of three parts: flexor, parser, and abstract syntax tree. Now my friend Satish will take over.
This is Satish. So coming to our grammar, our language consists of statements, and our statement consists of an assignment, loop, condition, variable, and a display and a read. So our display is a print statement and read is a scan statement. So scan is used to read an user input and display is used to either display the result of the program or display constant value. So coming to the equality, our equality conditions are used in the if and while loops, whereas the assignments are used to take care of the assignment part in the program. And our program has the while loop, the if condition, and if then else conditions. It even has expressions, strings, and integers. So coming to the graphical part of our grammar, as already said, our program is composed of statements. Statements, it can be any number of statements, one or more. And our statement will consist of either an assignment, loop, condition, variable, display, and the read. And our assignment statement is an identifier that follows by an equal to, and then it can either be an expression or a character, and our assignment ends with a semicolon. Whereas an equality operation, our program handles greater than, less than or equal to, equals, not equals, and greater than equals to. Whereas a while loop has starts with a while and then takes the condition, and it will have any number of statements and ends with a closing braces. Our variable, our program supports one integer data type, so it starts with an int open followed by an open braces and then the variable name and followed by a closed braces, and then we can either assign that a value or we can use it for later purposes. Our if condition is comprised of if condition and else condition, and in the in the if part, it's as similar to while part. We'll have the equality and then followed by the statements. The else part will start by the else and it will have the statement part. In our print statement, it has two parts. Our print will either display the value of the variable that is being declared in the program or a constant value. It can either be a string or a character. Coming to the scan part. So our scan part, scan of a variable name will scan the variable from the user. It will scan the input from the user and then store that value into the variable specified in the scan. This is how our expression looks like, and these are all the terminals of our program. The identifiers, the characters, the boolean value, the assignment statements, the greater than, less than, and all this. Coming to the implementation of the intermediate code, the infinity.g4 is passed to the Antler, and Antler will generate us all these files: infinity base listener, infinity base visitor, infinity lecture, and all these paths. So the Antler will generate the parse tree, and infinity base listener.java will run through all the will run through the tokens that has been generated by Antler, and based upon those tokens we'll try to walk through the grammar and then generate the intermediate code at each and every step of the program. Suppose as seen above below before, our program consists of, and our program starts with a statement. So where entering the program is where we actually start the program, and this is where we end the program. Our intermediate code at the end will end with the keyword end. So coming to the equality, when we encounter an equality operation, we will see that if the identifier in the equality part has, if it's not equal to null, then we'll push that into the add. So our intermediate code, we are using an array list called intermediate, and using this array list, we are adding all the intermediate code into the array list, and then these stack values are used to store the line numbers, and these line numbers are used to implement the jump part in the if and while statements. In line number, we are using line number to track the line number. Whenever we are pushing the value into the array list, we are incrementing the line number by 1. So this is how our code for intermediate code generation looks like. So we are having an infinity another Java file. This will actually parse the infinity lecture. We'll initially create an Antler input stream, and we'll pass our file into that Antler input stream. This will generate tokens, and that input is passed to the infinity lecture, and this will generate the tokens, and that is then passed to the infinity parser. The infinity parser will generate the parse tree, and the generated parse tree is used by the program to run through the entire parse tree and then generate the files. They generate the required intermediate code at each and every step of the program. Our intermediate code, whatever array list we are using, we are adding all the elements in the array list into the intermediate dot byte code over here. So this is how our intermediate code is generated in the intermediate.byte file. Now my friend Dikshit will continue the runtime part. Thank you.
We are using GitHub to version our project, and the project structure is same as expected by the project description. And we have the source, and within the source we have compiler and runtime. And you can clone the repository using the git clone. You can just say git clone and command V, and then you can just clone the repository. And once you clone the repository, you can use your favorite IDE. Either it can be an IntelliJ or Eclipse. As far as now, we are using IntelliJ. You can open the project, just go to your project path, and we have cloned it to SER502 project, and then just try opening the build.gradle file. And you have to open the project as you have to open the build.gradle file as a project, and we are using Java 1.8 and the JVM of 1.8. Then just click on OK, and then yes, and then you can either delete the existing project or import, or you can open the existing project. And now we are just opening the existing project, and we have the same directory structure as expected, but just two more intermediate directories, main and Java, for Gradle to automatically detect the file, the main file. And then in the compiler portion, we have all the intermediate code generation part, and in the runtime is where the Infinity runtime is located. So this is one of the main class which actually takes the intermediate code and passes it to the closed class loader. And coming to the runtime part of it, runtime of Infinity language follows the same conventions of the CD calling convention. The runtime is implemented in Java, and we have actually given a great importance to the object-oriented principles. As you can see, we have segregated and modularized the code as much as possible. And the bytecode is loaded into the memory, and the line numbers are used to identify the sequence numbers. And you can just go to the runtime and just see we have actually using sequence numbers. And the operations of runtime starts with the sequence number of 1 and ends with the end command. And the runtime can understand various operations like push operation, pop operation, and the testf go to check the if condition, and test go to, and the store operation to store the variables. On a high level, the runtime is divided into three areas. The one is arithmetic, and the other is conditional, and the other thing is the logical operations. Arithmetic, as like we are supporting the basic operations like add, divide, modulus, multiply, and subtract. And the conditional, we are all supporting equal to, greater than equal to, less than equal to, and not equals. And we are also using the logical, the runtime also supports the logical operations, and we are just using the basic, we're just supporting the basic logical operations such as and, not, and or. And this runtime is heavily dependent on two data structures. One data structure as stack, and the other as symbol table. Stack we are using to just store the sequence of operations and pushing and popping, and symbol table to store the variable names. And yeah, that's it from the runtime part. Like how this runtime is integrated with the intermediate code and then with the grammar is explained by Pramod, one of our team member, and he will be explaining the whole complete flow with the examples. We have like 6 to 7 examples. Thank you.
Everyone, I am Pramod, and I'm going to continue from my teammate Dikshit. Now I'm going to take some examples and tell you the working of our language Infinity, and I'll also go through some examples. So the first example, we'll go through the scan and printing checking. So what scan A does is that it takes the input from the user. Print A prints the value which is inside the variable A, and print hello world is that we're printing the string hello world. So what this does is this command prints anything that is in between the parentheses, and we can run this file by giving the following command /gradle w build run -p file is equal to the file name and the .inf extension. So when we run that, we see that this is taking some time to run because we are using Gradle for our runtime. Gradle is an open source build automation system that builds upon the concepts of Apache Ant and Apache Maven and introduces a Groovy based domain specific language instead of the XML form used by Apache Maven for declaring the project configuration. So what this does is that Gradle is essentially a wrapper. So we are using this because so that we don't face any difficulties while we are implementing our project in different systems. I think I didn't run the proper file. So I actually executed the GC file. So I'm going to change the name to scan and print check. So we can see that it's taking some time, and and so when we execute this command, we are also going to generate the bytecode. In this bytecode, we can see the first command as read. Read, read. What it does, it takes the input from the user and it stores it in a variable A and pushes the value of A into the stack, and then it prints out the top of the stack. Similarly, we are also trying to print out the hello world string. uh, hello world pushes we push the hello world string into stack and we print it out, and then all our intermediate codes end with the command end. So since our program takes an input from the user, we have to give some input. Suppose I pass the number 5, say enter. We can see that it is printing out the value 5 and also printing out the string hello world again. So now we'll take the and now we'll take the Fibonacci series as an example. Here we are initializing the variables a and b to 1 and n to 100. So in our language, while initializing an integer, we have to give it in between the brackets or the parentheses, and also we are using a while loop to generate the numbers, and we're going to print it out. So we can run. We're going to change the file number here, file name here, Fibonacci, and then I'm going to run it. We can see that it's taking some time, and also the bytecode is going to be generated. So we can see the usual commands. The new commands are testf_goto and testtgoto. What testf_goto says is that if the condition inside the if condition is false, it goes to line number 25, and if the condition inside the if condition is true, it goes to line number 9. So we can see that line number 25 is the end of the program. So we can see here in Fibonacci series. So if this fails, I'm sorry, I used the word inside the if condition. It's actually inside the while condition. So if the expression inside the while condition is false, it goes to the end of the statement. So we can see that here. We can see that it goes to the end, and again, and similarly, if it's true, if it's true, it goes to the start of the while loop again and keeps on executing the program. And we can see that since we have given the limit of n is equal to 100 here, so it is only going to print out the Fibonacci series up to the number 100, and the next number in the series is above 100, so we're going to stop at 89. And another example is GCD. GCD we are going to find out the GCD of 60 and 120. So here we are using the while loop, and inside the while loop we are going to use an if loop, and we can run the same program. We can gcd.inf, and another bytecode is going to be generated for this, and we can see that the output says 60. So the GCD between the numbers 120 and 60 is going to be 60. And these are other examples saying this is swapping two numbers, and this is a little bit more complicated example. We're going to print a pattern which we have seen. So we can see it's going to take some time printing out a to generate the bytecode, since I haven't generated it before. So we're trying to print out a pattern of A's. So that is it. Thank you very much.